Alright, this is a video about skill 31, which is identifying the domain, range, and asymptote of exponential equations and logarithmic equations. And this is just doing it analytically, so just by looking at the equation, we're going to be able to tell those three things. First, it's important to be able to just identify what type of equation you're looking at. If we look at example 1, this is an exponential equation. We can tell that because we see the exponent has our variable in it. In example 2, this one's a little more obvious. This is a logarithmic equation because we see a logarithm here. To start with our exponential function, exponential functions all have the same domain. They are all defined at all values of x, meaning our domain is going to be from negative infinity to positive infinity. If we kind of just visualize the graph of maybe 2 to the x power, remember what that's going to look like is something like this. And notice how it extends all the way to the left and all the way to the right. That's why our domain for all exponential functions is going to be negative infinity to positive infinity. Before finding our range, it's actually helpful to think about the horizontal asymptote here. It's slightly easier to identify. Our horizontal asymptote is going to be y equals -1. And the reason for this is that all exponential functions, before we add any transformations, and by that I mean any shifts or any reflections, and remember in this question this is going to be a reflection, this is going to be a reflection, and this is going to be a shift. And so before we factor in any of these things, all exponential functions have a horizontal asymptote at y equals 0, at the x-axis. We can kind of see right here, if we look at 2 to the x, there's no shifts, no transformations, so there's a horizontal asymptote at y equals 0. That horizontal asymptote is only going to be affected by a downward shift. And in this problem, we have a shift down 1 unit right here. And so that's why our horizontal asymptote is going to shift down 1 to be at y equals -1. And if we think about what this does for this graph, it's going to divide all of our y values on the graph into two different categories. There's those that are below our horizontal asymptote at y equals -1, and there are those that are above it. And basically for our range, we just need to pick the correct one. In this graph, we can know our range is going to be the bottom half of this graph because we have a reflection over the x-axis right here. All right, remember, a negative in front of our function is going to be a reflection over the x-axis. That's going to make our entire graph reflect so that it's underneath our asymptote, which means our range is going to be from negative infinity to our horizontal asymptote at -1. If we move on to this logarithm, it's easiest to start by thinking about our range. Because remember, all logarithms have the same range. All logarithms have a range of negative infinity to positive infinity. And this is because logarithms are the inverses of exponential functions. So it makes sense that all exponential functions have a domain of negative infinity to positive infinity, and then that their inverses, logarithms, have a range that's that same domain. Remember, the domain of one is going to be the range of the other. So now if I want to find the domain of this function, what I can actually do is I can take the argument, and remember when I say argument, what I'm referring to is the inside of our logarithm. So in this case, I'm looking at the argument right here. I can take the argument, and if I want to find the domain, I'm going to set it greater than 0. So I'll solve this. I'll add x to both sides. So I'll have 6 is greater than x. 6 is greater than x. And that's going to be my domain written as an inequality. If I want to think about rewriting that domain as interval notation, I'd say, all right, 6 needs to be greater than every single x value. So my domain is going to be from negative infinity to 6. That's going to be my domain. The vertical asymptote I can find by taking that same argument, negative x plus 6, and setting it equal to 0. Whatever number, whatever value of x makes the argument of my logarithm 0 is going to be where my vertical asymptote is. So add x to both sides, and so 6 is going to equal x. So that's the equation of my vertical asymptote. A couple pointers just as we look at these examples. A couple common mistakes would be forgetting to make horizontal asymptotes y equals something and vertical asymptotes x equals something. And I think that's probably the biggest one. Aside from forgetting to correctly write an inequality in interval notation. Just because the 6 is on the left side of this inequality does not mean it belongs on the left side of interval notation. 6 is greater than x, which means it should be the largest number in this interval. And we're always going to put the largest number on the right side of the interval. Alright, that's skill 31. Finding logarithms and exponential functions, domain, range, and asymptotes.